Hey, Ag Teacher Thoughts here, coming at you with another video. Well, it's a hot one today. It's 105. So I'm trying to hang out in the shade. I got some stuff done earlier, and then I'll wait till it gets a little bit cooler to start working outside again. So yeah, I figured it was time we talked a little bit about mutations in flower blossoms and how that can give us different shapes and forms when it comes to flowers like petunias and peonies and roses. So let's do a little bit of scientific learning about how a mutation can affect the appearance of, in this case, specifically petunia blossoms. So what we're going to look at here is we're going to look at the standard shape of a petunia and the layout of how this is arranged. Now, one of the things for you to note, so you see how this flower here has this dark pink streak that comes right down the center. That is the center line of this individual petal. So that goes from this notch past this streak, which is their central vein, all the way to this notch over here. And this right here is one petal. So on petunias, you have 1, 2, 3, 4, 5 petals. It's a 5-petal arrangement. That's one of the ways that we know that this is in the nightshade family, is a 5-petal arrangement. Now, at some point in time, these petals did fuse together. So instead of having a separation between these petals, they just fused together. So there was a mutation at one point in time that led to that. So when we have a flower, we need to kind of think about the standard arrangement. So this is a standard petunia, and this is arranged, and these are your parts of the flower. You have your sepal, which is this part right here. All right, so those 5 little leaf-colored, vaguely petal-shaped parts. So those are the sepals. That's what protects that blossom when it's really young. So sepal. This part up here is our petal. Inside, way down inside, we don't have the tweezers. Way down inside, we have our stamen, and then we have our pistil, but we're going to call this a carpel at this point. So our layout goes sepal, petal, stamen, pistil, or sepal, petal, stamen, carpel, right? All right, so there is your female reproductive organ, there's your male reproductive organ, and these are your attractant structures that bring insects into the blossom. Now, with these, there can be mutations that occur that actually change some of these parts into other things. So with our flowers, we have 1, 2, 3, 4 locations. So think of like 4 slots on a flower. And at any given time with a mutation, any of these 4 objects or these 4 structures can turn into any of the other structures. So you could technically have a sepal turn into a petal, which would then be called a tepal, right? So you can change these two, so you'd have 2 petals out here. You could change out a petal and a stamen so that you have a petal and a petal. You could have a petal here, a stamen, a petal, a sepal. So there's all sorts of arrangements that we can have that can be a little bit different. And to know which one has changed in a mutation, you're actually going to have to cut the flower open and take a look. So we'll take a look on this petunia first so we can see what a standard layout is. Okay, let's see if I can get this cut efficiently. You've seen me cut a lot of these petals off lately if you've been watching me do the fertilization. Okay, let's get you really close so we can see that layout. Okay, so on this flower, we have our stamen. So these are the male reproductive organ. So this is the anther, and the stamen is the little guy right up top. Okay, so that's the male reproductive organ. Way back here in the back, let's get these out of here. We'll remove the stamen. Here, I'll put one right there so you can see a stamen. Okay, there's the stamen on its anther. Okay. And then what we have remaining in here is our pistil. So that's the female reproductive part. All right. So there's our female reproductive part, and this is actually tacky. It's got some sugars on it that actually hold on to the pollen. Down in here further, if we keep digging down here, it's all the way down at the bottom. We would actually find the ovary. Okay, so there's the ovary right there. That's what grows into a little acorn shape for our seeds. So that's our ovary down there. So there's the pistil. There's the stamen. Let's see if we can get it to stay. There's a sepal. See if I can get just one petal. And there's a petal. Okay. So these are all of our reproductive structures in a regular petunia flower. So that is your pistil, stamen, sepal, and petal. So on this we can actually take and we can exchange. You know, this is normally where your petal is, right? Your petal's right there. We can actually exchange it to where you get petals in other locations. So we can put 2 petals there. So you eliminate the stamen and you have 2 petals. You could also go in and eliminate the carpel and you can have 3 sets of petals. And also, if you really had one that was kind of crazy, you could actually replace the sepal with a petal. So you would have petal, 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 petal. Or any of these combinations of which you could have a stamen in its stamen spot, petal, stamen, petal, petal. Or you could have this one here in its spot. So you could go petal, stamen, petal, sepal. Or the really weird thing is you can actually swap out any of these structures for any other structures. So you can have a flower that is nothing but stamens, or a flower that's nothing but carpels. So you can change those out. Okay, so let's look a little bit further. And we're going to get to some real world examples. So hold on there. The learning's going to keep going. Okay, so hopefully you've got kind of the idea of what we can do on our arrangements here. And I've drawn up a couple of examples for us. Okay, so here's one of the mutations that could occur. So we can have a carpel, a petal, and a sepal, right? So this would be like a double blossom, all right? We could also exchange the carpel out for a petal. So it would go petal, stamen, petal, sepal. You could be getting really full, almost like a rose, or like a regular rose that you would recognize, where you've got petal, 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 sepal. This is a very, very common arrangement on roses or peonies. Peonies can be a lot like this. And the last one, if you got really wild and crazy, you could have all 4 of your structures be petals. So with our petunias, this is the common layout that you typically see. So it's sepal, petal, stamen, carpel. Okay, so this is our standard petunia, but what we're going to do is we're going to look at some petunias that are a little bit different, and they're actually in this arrangement here. So I've got Vogue Lavender Vein, which is a double, and then I've got Lemon Berry, which is a double. So these are our double petunias here, and this is what we're going to do some breeding work. We're going to see if we can get some of this material in here into our Firefly petunias. So this is our Lavender Vein, and this is our Lemon Berry. So these are doubles. This one's a little bit older, but it's got good pollen in it, so that's why I grabbed that one. So the arrangement of this one is we do have our sepals on the outside, then we've got petals, we've got stamen, and then we've got petal again. So when you have this layout on these, the problem with that is if you are if you are missing one of the the reproductive structures on a flower, you make it, in essence, sterile. So on this one, there's no female reproductive organ here. So this flower cannot form seed. However, this one does have the male reproductive structures, so it can actually provide pollen to a flower that does have a female reproductive organ. And maybe that flower has the reproductive organ that's female, but it doesn't have the male reproductive organ. So if you had that layout where this was what you were working with, you were taking your pollen from this, but then you were, see if I've got that layout. Nope. But you had one that had the female reproductive organ but didn't have the male reproductive organ, then you could actually pollinate that flower that has only the female organ with the flower that only has the male organ. And if you have something like that, then you have a chance to get one where it comes out this way. There is a chance that you will grab some of that genetic information, or actually, in this case, eliminate that, where you'd have a petal instead of a female reproductive organ, a petal instead of a male reproductive organ, and your regular petal. And this would be a completely sterile flower. So you can't do any breeding work with this. There's no reproductive organs to work with. So if you wanted this kind of rose-styled blossom, you'd have to find one with an intact female and one with an intact male, and you cross those, and then some of those offspring may be missing enough genetic material to give you this, this rose style. Okay, so let's go ahead and we're going to look at some of these, but as we do it, we're going to do some pollination. So I'm going to, I think we're going to work first with the lemon berry. So these are going to be first generations. So we're going to do firefly crossed with lemon berry. Okay, that's going to be our cross there. And the rest of this process is going to go fairly similar to the way that it has before. So let me get it prepped real quick. Okay, so I'll grab one of these good blossoms over here out of my water. And we're going to go ahead and start going through and dissecting this flower. So there is a petal. So that's not a fused petal, so that's okay. So we've got a petal there. Got another petal. So we're going to just kind of take this one apart. Oh, this is trying to form our regular style petunia blossom. Okay. We go in here, and what else do we have? We have some of the stamens. You can see that this one is actually a really kind of complex one, in that some of these structures here, there's a little bit of pollen here where there's a little bit of a stamen structure that's actually been mutated too. And then there's no, this right here is a petal, and that's this structure right here. So it's got the stamen, but it's not got the other petals. So we're going to go ahead, we're going to grab some of these out. I may have to use a different tool. A lot of pollen on these. These are really good pollen producers. Probably won't need a whole lot. Okay, so I got my pollen. And I'm going to go in here and do our normal pollination. Okay, seems to run out of pollen there. Got a little bit more there. Kind of an awkward format. There's some good ones. Yeah, that should be some good pollination. Seen a lot of pollen transfer. Yeah, there's a lot of material there to work with. Okay, let's see if we can do a few more. All right. Got a few more of these. I'm just going to kind of go crazy. And then there's just all sorts of stamen-like structures down there and a ton of pollen. So we're going to grab that. We're going to put it in there. Grab another donor. And this donor, same deal. A lot of these stamen are actually mutated. So I can come in and actually grab some of that material off of there. Because there is actually pollen on there, even though it's not a complete structure. Well, that plant looks a whole lot different. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 blossoms have been pollinated, so we're hoping that that's going to work. Okay, so that's our lemon berry. Now I do have a second one, which is our purple vein, our Vogue purple vein. That's a double. Okay, so this is our next one. This is the first generation. It's a double. Probably should write that on this one over here too. Okay, so those are both doubles. And I think this is the same layout, so let's take a look at it. So we have our sepal. We have our standard petals here, so petals all the way around. And then let's see what's been converted. Oh, well, we've got stamen. There's stamens. The stamens are partially converted to petals. Yeah. See that? That structure right there is the stamen. But that anther is converted to a petal. So that's what we're dealing with here. I don't know if these are open. I don't know if there's any pollen on these. I do not see any pollen ripe on there. So yeah, everything's been converted on this one. So this one, there's a little bit of the male organ on there, but really this is what we're looking at. We've got our petal, petal, petal on this one. So our petal on the outside, sepals are still there. Stamen are partially converted to a petal. See, they've got petal structure to them. And then the carpel is completely converted. So I'm not, and there's way more stamen than there should be. So there should be, yeah, I think it should be 5 stamen, and there's like, well, we pulled one off already. Well, there's a lot. There's a lot more than there should be. But I do not see any pollen on this. This may be completely sterile. If it is, that's disappointing. Yeah, I do not see any of these that are ripe. So there's no pistil structure, so we can't cross that direction. And there's no pollen on this. We check the other 2 blossoms. maybe. Let's see. Yeah, that one had pollen on it. So I'm going to try not to lose this. We'll see how many of these I can do. The other ones just weren't ripe yet. So the pollen's blue, so I can see it transferring. Just add a pollen on that one. Okay, so let's see how many more of those we can do in that same general area. This one will be very interesting. Even if we don't get a strong glow on it, it should be rather interesting. The problem is, though, is to find stamen that are ripe. See one right there? Yep. I just ripped him off. He was ripe, had pollen on him too. I should have used my other tool. Okay, there's a couple of ripe stamen. Okay, good. Good. Let's use my locking hemostats. There we go. Got a stamen there. And we'll find ones that haven't been pollinated. Yeah, I think that's all of them. All of them I had done. And I'll go through and mark them later. So anyway, I hope you're learning something about this as far as the layout of flowers and petunias. And by all means, if you're learning something and you're enjoying the content, please do subscribe. Click the bell for notifications, do all that YouTube stuff. Sit and watch it with your plants. Plants do like music. They grow better. I'm not singing, but maybe me talking about plants will make them happier. But yeah, if you enjoy this channel, please definitely do subscribe and watch our videos all the way to the end. You know, there's a lot of times I've got other stuff going on at the end of the video, and if you haven't caught those yet, you might be kind of pleasantly surprised. But anyway, as always, I hope you learned something. I hope you enjoyed. Ag Teacher Thoughts out. Hey, thanks for sticking around. If you didn't know it, this is what an onion looks like when it goes to seed. So if you haven't grown something yourself, these are onions. This is an onion seed right there. This little black kind of wedge-shaped thing. These are well, they're in the Walla Walla Sweet variety, but you can't call them Walla Walla Sweets unless they're grown in the Walla Walla area of Washington. But these are definitely sweet onion seeds. And if you didn't know, onions can last more than 1 year. It's not just a 1 year thing. So if I plant these, they'll be ready to harvest next fall. So if I plant them here now, they do need to kind of run through a winter. Whoop, planted. But yeah, that's what onion seeds look like. They're kind of fun. I'll probably be stratifying some of those. I've got a couple of seed heads of these collected, but I'll stratify those for about 10 weeks, which means they'll be in moist soil in my refrigerator for 10 weeks. And then we'll plant them up in the greenhouse and get them running for spring. But yeah, these are actually, I think they're 3-year-old onions. So they do form a bulb, and they've been coming back year after year for the last few years. But anyway, thanks for joining me. See ya.